So in 9.4, we are going to be graphing sine and cosine functions. So we're going to be exploring characteristics of sine and cosine functions. So this first graph here is the graph of the sine graph. Second one is cosine. They look super similar and they have all the same properties. However, sine starts at 0 and cosine starts at 1. So the two important differences is that sine starts at 0, cosine starts at 1. Other than that, they have the same shape pretty much. This section's super heavy on vocab, which we'll get to more in the next couple of slides, but we're going to focus on just one period of the graph. So period is just going to be from 0 to 2 pi unless we have some type of transformation that changes our graph. But it's just like one cycle, and then after that one cycle in that first period, the graph just repeats and repeats and repeats. So it's just the same thing over and over again. The standard increments in our first period that we're going to be focusing on are 0 to 2 pi. So these numbers up here are the standard increments. Which sometimes our increments will change, which again, we'll get to that in a couple slides. And then another vocab word we want to focus on is our amplitude. So our amplitude goes from 0 to 1 in our basic graph, but sometimes when we have transformations, that'll change. The next page. So the domain of each function is all real numbers. So domain goes from left to right, it's all of our x values. Our graph goes forever in the negative direction and forever in the positive direction, so our domain is all real numbers. Our range is from -1 to 1. So if you see, our graph never goes below -1 and never goes above +1. Our range is just the y values in between here. So from -1 to 1. The amplitude of the graph of each function is 1/2 the difference of the maximum value and the minimum value. So the amplitude is just going to be from 0 to 1. So that's our amplitude. Just like half of our graph, but it's just like the positive half. So from 0 to 1. Each function is periodic, which means its graph has a repetition pattern. The shortest repeating portion of the graph is called a cycle. The horizontal length of each graph is called the period. Each graph shown above has a period of 2 pi. So the period, we're just going to be focusing on one period here. So just from 0 to 2 pi and from 0 to 2 pi. There's one period of the graph. So let's go to... So sometimes our sine and cosine graphs will change depending on numbers that are being multiplied to them. So if we have a number that's being multiplied out front of our graph, that affects our amplitude. So instead of being from 1 to -1, our graph would go from like a to -a, whatever this value is here. So the a, that number out front, affects the amplitude. The b, so a number that's being multiplied to x, affects our period. We find our period by dividing 2 pi by that number b. So sometimes it'll be like a number like 4, sometimes it'll be 2 pi that's in front of x. So whatever that number is that's in front of that x that's being multiplied to x, that helps us find our period. We do 2 pi divided by b to find the period. So every graph, we're going to need to find our amplitude and our period, and we also need to find the increments. So to find our increments of our graph, we take our period and divide it by 4. So if we look at that little paragraph to the right, it says each graph below shows 5 key points that partition the interval 0 to 2 pi into 4 equal parts. So those 4 equal parts are our increments. And every time we graph our sine and cosine graph, we are going to need 5 key points. Remember, our sine graph always starts at 0, and our cosine graph always starts at our amplitude. So the two differences. And then we never go past what our amplitude is. So we're always just oscillating in between our amplitude, so we just stay within those boundaries. So we're never going to go above that amplitude, we're never going to go below it. So let's look at our first example. We need to identify the amplitude and period of g of x is equal to 4 sine of x, and then we need to graph. So we're going to have our graph here. What is our amplitude? So remember, our amplitude is the number that's being multiplied out front. We don't need to worry about the absolute value. It's always going to be positive, so it's just 4. So our amplitude is 4. Our amplitude goes from 0 up to 4. And then we go from 0 down to 4. So our amplitude is 4. That means our graph goes up to 4 and down to negative 4. Next, we want to find our period. So period is 2 pi divided by b. And b is the number that's being multiplied to x. Do we have a number that's being multiplied to x there? Just 1. So our period would be 2 pi. So our graph is going to go from 0 to 2 pi. Now we want to find our increments in between. So we're always going to need to find 3 more increments in between 0 and whatever your period is. So our increments, we take our period, which is 2 pi, and divide it by 4. What is 2 pi divided by 4? Pi over 2. So this is our starting increment here, pi over 2. And then we just keep adding pi over 2, pi over 2, pi over 2 until we get to 2 pi. So pi over 2 plus pi over 2 would be what? So we add the tops together. Pi plus pi is 2 pi. You're right. And then the bottom stays the same. So 2. So it would just be pi. And then we add another pi over 2 to it. So we just keep adding this pi over 2 each time. So add another pi over 2. What do we get? 3 pi over 2. And then we can add another pi over 2 to it. And we get 2 pi, which is where we stop. Once we have our amplitude, our period, and our increments, we can go ahead and graph. So this is a sine graph. So our sine starts at 0. It always starts at 0 and then goes up. So we're going to go up to 4 at our next increment. We're never going to go past 4. So once we hit that top boundary, we go back down to 0. Then down to negative 4. We never go down past negative 4, so we have to go back up now. So back up to 0. And these are our 5 key points. Once we have our 5 key points, we just draw our line in between. It's not very good, but Probably as good as it's going to get. There we go. Example 2. So we're going to graph it, and we need to find our amplitude and our period. So what is our amplitude here? Number that's being multiplied out front. 1/2. So our graph is going to go up to 1/2 and down to -1/2. It's just going to bounce back and forth in between these two. Next, we want to find our period. So we take the number that's being multiplied, or 2 pi divided by our b, which is the number multiplied to x. So 2 pi divided by, what's our b? 2 pi. What's 2 pi divided by 2 pi? 1. So our period is 1. So we end at 1. Now we want to find our increments. So we always take our period and divide by 4. So our starting increment is 1/4. And then we just keep adding whatever increment we got to start, we keep adding and adding and adding as we go. So 1/4 plus 1/4 would be what? 2/4, which is 1/2. And then we just keep adding another 1/4. So what is 2/4 plus 1/4? 3/4. And then 3/4 plus another 1/4 would be 4/4, which is 1, and that's where we stop. You're always going to have 3 increments in between 0 and your period. It's always just going to be split up into 4 nice little sections. That's why we divide it by 4 to find our increments. So here we have our cosine graph. Cosine graph starts at what? 1, but it starts at our amplitude, which here it's 1/2. So we can't go any farther past 1/2, so now we just have to go down. So we would go down to 0. Where should we go next? Awesome. We go back down to -1/2. And then where? Go back up to 0. Awesome. Then back up to 1/2. And then we can just connect our dots. Can't really draw a nice squiggly line today, but we get the point. So those are 5 key points and our cosine graph. So for all of your graphs, I need to see the amplitude, the period, and your increments. And then the 5 key points in your little graph. Any questions? So let's do 3 and 4. And then if you need more practice, we could do 1 and 2 after. But let's look at number 3. So what is our amplitude for number 3? Number 3, yeah. 2. It's what's being multiplied out front, so our amplitude is 2. So we're going to go up to 2 and down to negative 2. Next, we want to find the period. So our period, we divide 2 pi by b. What is our b here? Pi. That number that's being multiplied to x, so pi. So what's 2 pi divided by pi? 2. So our period ends at 2. And then we want to find our increments. So we take our period and divide it by 4. What's 2 divided by 4? 1/2. So our first increment is at 1/2. How do we find the next one? Or 1/2. So we add 1/2 to it. 1/2 plus 1/2 is 2 over 2, which is 1.
1.
And then how do we find the next one? We add 1/2 again. So 2 over 2 plus 1 over 2 would be 3 over 2. Now this is a sine graph. So where does our sine graph start? At 0. So at 0, where do we go? Up to 2. Then where do we go next? Back to 0. Down to negative 2. And then back to 0. Those are 5 key points, and we just draw our curve. All right, let's do one more. Let's look at number 4. So we're going to draw our graph, and then start with our amplitude. What is our amplitude? 1/3. So that means we go up to 1/3 and down to negative 1/3. What should we find next? The period. How do we find the period? 2 pi over b, and what's our b? 1/2. Oh no, dividing with a fraction. What do we do? Keep, change, flip. Keep the top, change to multiplication, flip the bottom. So we have 2 pi times 2 over 1, which is 4 pi. So our period ends at 4 pi. What should we do next? Find our increments. How do we find the increments? The period, which is 4 pi over 4. What's 4 pi over 4 simplified to? Just pi. So our first increment is pi. And then we just keep adding pi until we get to 4 pi. So it's pi plus pi. 2 pi. So then we have 2 pi, and what's 2 pi plus pi? 3 pi. So this is a cosine graph. Where do we start? Start at 1/3. Where do we go next? We go back down to 0. And then where do we go? Negative 1/3. And then back to 0. And then back to 1/3. And we just connect our dots.